Only 4 students in the whole country were successfully able to answer this recent Junior Maths Olympiad problem. It took me about 15 seconds. So what's the problem? Suppose we're allowed to put squares together of the same size and we could have as many squares as we want. Then you can see in this particular example, it forms a 6-sided polygon, a hexagon. And the question is, what different number of sides is possible when you put the squares together? Now, if you just had a single square, then we can see that 4 sides is possible. And we can see also above that 6 sides is possible. 8 sides is also possible, 10 sides is also possible. So it seems to be we can get any even number of sides that's at least 4. But how could we prove it? And how can we prove that we can't get an odd number of sides? Now suppose we start with a 2x1 rectangle like this. At the moment it has 4 sides. Now each time we add an individual square in a zigzag type fashion, we add 2 more sides. So if we add a square like this, we now have a 6-sided shape. And if we added a square like this on the end, that gives you 2 more sides, so we can get an 8-sided shape. And if you add a square in the bottom again, we now have a 10-sided shape. And it's easy to show that as we keep on adding squares in this diagonal type fashion, we can keep on adding 2 to the number of side lengths. So we've therefore proven it's possible to get every even number that's at least 4. But what most students fail to do in this exam is prove that you can't get an odd number of sides. And there's a really easy way to show that. Let's suppose we started at this point here. Then as we go around the edge of the shape, we do horizontal, then vertical, then horizontal, then vertical, then horizontal, vertical, horizontal, vertical, horizontal, and then vertical. So we always rotate between horizontal and vertical, and we have the same number of horizontal lines as vertical lines, and therefore there must be an even number of sides of the polygon, and therefore we've proven there can't be an odd number of sides.